Now let's see what have we done for its software. Let us start with the home screen. On top of this screen, as in all other screens, there are 10 active icons. Each icon gives an overall indication of an item, and then when clicked, opens another screen which shows details. From left to right, there are Ethernet, Wi-Fi, UHF, GSM, GPRS, and Bluetooth. On the right side, there are satellites icon, current map icon, current settings icon, display and speaker icon, and battery status icon. You can click on each icon and see details. For example, the satellites icon, when clicked, shows 20 satellites are being tracked. If you click this icon, you will see the satellite details, which shows satellites' names, azimuth, elevation angle, health status, and their up to 5 signal strengths. Or you can click the battery icon to see the history of battery performance. Also see temperature in different sections of the receiver. This is a great tool to see information in different environmental conditions. On the main sections of the home page, there are many icons. Let's focus on the settings icon. Clicking the settings, you'll access screens to program the operation of the receiver for a variety of applications. Then you can store settings in an unlimited number of files. You can also assign 5 sets of settings to 5 function buttons on top of the receiver for instant reloading of the settings. Let's see some examples. For example, I will program the receiver to track GPS, GLONASS, Galileo, and SBAS satellites. Then I select the receiver to receive RTK corrections via UHF, and I specify the format to be RTCM3. I also limit elevation angles of satellites to 5 degrees. In the duration screen, I can specify the duration to be manual, timed, scheduled, or accuracy dependent. Here, I specify the duration to be until accuracy of better than 3 centimeters is achieved. In the communication screen, I can set up all of my communication channels of UHF, Bluetooth, LAN, GSM, GPRS, and Wi-Fi. For example, for UHF, I select the frequency, output power, and UHF protocols. In the antenna section, I can enter antenna height and specify the type of external antenna if an external GNSS antenna is connected. In photos and voice, I can specify bottom camera's resolution, also the memory location to record images, and also how often to record. I select the bottom camera to record an image once at start and once at the end of the survey. I can do similar with the top camera. I can also program the voice recorder to automatically record my voice for 20 seconds when I start the operation. I can also program that all operations start with 5 seconds of delay after I click the start button to align myself better. I will skip other settings for now. After I program Triumph VS for my particular application, I can store them in a file and later reload them when I need them. I can record unlimited number of settings in such files. I also can assign 5 of my settings to the 5 function buttons on the top of Triumph VS. I save my settings in a file, and I also assign it to function button F1. As another example, I program the receiver to act as a base station and transmit RTCM messages every second via Ethernet. I program Ethernet parameters, antenna, photo, and voice settings, and then store these settings in another file and assign the settings to the F2 function button. Now each time I push the F1 button, my receiver will instantly load my F1 settings. The same with F2 through F5 buttons. You can program a variety of scenarios and then recall them instantly. Now that we have programmed our Triumph VS, let's see how easy it is to use it in the field in a variety of applications. In the field, all you need to do is to turn the receiver on, push the desired function button to make sure that your settings are what you want. Then push the action button in front of the receiver. In action screen, again, active icons are on the top. All you need to know in doing your projects are shown in the action screen. I'll try to explain them briefly. On the top left is the timer box. In manual duration, it shows the elapsed time. In timed operation, which is the case here, it shows the elapsed time and the remaining time. Below the timer box is the satellites box for GPS, GLONASS, Galileo, WAAS, EGNOS, and QZSS. Below each flag, on the left side, is the number of satellites tracked, and on the right side is the number of satellites used. Below the satellites box are two boxes for transmit and receive. In this example, nothing is programmed to transmit. The receive box shows it is ready to receive RTCM data. It also shows the quality of the communication line. Next is the memory box, which shows total amount and the remaining memory sizes. On the right side, on the top, is the epic counter. It counts epics when action starts. The box below that is for front camera or to count down delay timer, if any. Next box is the position box, which shows the calculations for the action in progress. In survey operations, it shows running average of coordinates. In stakeout, it shows the offset from the target. At the end of a parcel survey, it shows area and perimeter of the parcel, which is the case here. Next is the position calculation type and estimated accuracy. Here we see RTK fixed is in progress, and the estimated accuracy is 3 centimeters. Next is the recording box. It shows the format and the period of data recording. In this example, the header of the screen shows the parcel name and the parcel point being surveyed. Next is vertical and horizontal level indicators and numbers. Next is the compass indicator and heading. In the footer of the screen is the instantaneous coordinates of the current point. On the right side of the action screen are buttons to control the action. Start and stop are on the top. Clear clears the screen. The next two buttons vary based on the programmed action. In this case, they control the parcel survey and when to end it. View button selects what should be shown in the action screen. Next is Review button. You can view the results of the survey. And finally, the antenna icon allows a quick way to enter antenna height. When voice recording is in progress, the audio recording indicator appears here. In the center of the display is the position plotter. If you open the bottom camera, the center of the display is the center of the receiver for alignment with the mark. The screen scale can be changed by zoom buttons. Now let's see how to survey a parcel, for example. We have set up for parcel survey and selected the RTK mode. We have set duration of 10 seconds. With this setup, we go to the first point, align to the mark, and click Start. We do nothing else. The timer will count down, and each calculation is shown on the screen. The final result is stored after 10 seconds. Then we go to the second point and repeat the same. Just align with the mark and click the Start button. We repeat this for all corners of the parcel. After the last point, we click the End Parcel icon. The parcel area and perimeter are automatically shown in the position box. We can also record raw GNSS data in case we want to document survey data or for post-processing it. Other survey jobs are even easier than this. To do stakeout, just select the stakeout mode, select the stake point, and Triumph VS will guide you to the point to stake it. After stakeout is done, you can survey the actual stake with a simple click. Triumph VS will record the intended stake point along with the actual point in the same file and will show the difference. Let me show you one more example. You can survey many points and then convert them to smooth shapes via the Draw menu. Here you can curve fit the points to a single point, a line, a second degree, or a third degree polynomial, a circle, etc.